Hello friends, welcome to your own channel on artificial intelligence and machine learning. We are learning SQL programming. So far, as part of this playlist, we have learned DDL statements, the data types, DDL constraints. In our last session, we had covered foreign key and unique key concept. In this part of the video, we are going to learn about indexes. By the way, if you have been following the videos all throughout and you have been enjoying learning from these videos, I request you to hit the like button. If you have come first time to the channel, I request you to kindly subscribe to the channel. Okay, let's move forward. Let's try to understand the concept of indexes and why do we need indexes. Assume you are working with a bank and you have a table customer, and in this table you have millions of customers. The IDs are like 1 2 3 4 and so forth, and you have say 1 million customers. There are many other fields: name, date of birth, date of join, date of basically account opening, date of creation, and so forth. You want to fetch data of a specific customer and you write a query, select star from customer where ID is equal to 5085. Assuming you have not declared this column as a primary key, there is no index on the table. Okay, once again, please hear, there is no index. In that case, the database query engine will scan each and every record to check whether the value of this ID is equal to 5085. Somewhere here you have a record 5085. However, the query engine scanned all the records to find which all record ID matches 5085, and this is called full table scan. You can clearly see this is an inefficient way of searching the data. This is where indexes come into play. Now, in case you have an index, there are two types of indexes. Primary key creates a clustered index, and then there is another type of index called non-clustered index. So broadly speaking, there are two types of indexes: clustered, non-clustered. The way these index information is stored, that is B tree. So let's now try to understand B tree. Assume we have an index on the ID column. Technically, the ID column should be a primary key, and automatically a primary key will create a clustered index. But for the time being, I'm trying to explain the concept of index. So I'll not go into the difference between clustered and non-clustered. First, you understand the concept of index. So on the ID, we have a index created. Create index, index name on table, table name, bracket, column, whichever columns on which you want to create. You can create an index using create index syntax. So this is a root. Now we have millions of record. The B tree would store data something like this. This is your one of the internal node. Here information is say 1 to 100k, 100k to 200k, and 200k to 300k. And then here you have another node which has from 300k onwards to 400k, 500k, and up to 600k, and like that you would have here from 600k, 700, 800, 900, and 1 million completely. Okay, now this nodes would be probably further split something like this: 1 to 25k, 25 to 50k, 50 to 75k, and 75k to 100k. Similarly, this would be further split. Okay, then this would be further split probably 1 to 5k. These cutoff points I'm just putting. You just imagine that the tree would take care of all of these things. Don't worry about it. 10k to 15, 15 to 20k, and here 25k. Now you are writing a query. Select star from where ID is equal to 5085. So it will come to the root node, the query engine of the database. It would come to the root node, and from root node it will say where 5085 would lie. Here you can see the range is 1 to 300k, and here the range is 300k to 600k, and this one is 600k to 1 million. Obviously 5085 would be here. So starting from the root node, the query engine will understand first it has to come here. Now these are the cutoff points: 1 to 100k, 100k to 200k, and from that it will realize, okay, I need to navigate here. And here once again the cutoff points are there: 1 to 25, 25 to 50, and so forth. It will understand it has to navigate here on this side. But now this one is 1 to 5k, and then you have 5 to 10k, which means this navigation would come here. This way, instead of doing a full table scan, you can see using a index which stores the data for the indexed column in a B-tree format, we have been able to quickly identify where 5085 ID information would be. And once you reach here, you quickly retrieve the information. This is the advantage of an index on a table. If you search the data based on the indexed column, your select query will run fast. You avoid full table scan. I hope the concept of index is clear. Now let us try to understand difference between a clustered index and a non-clustered index. Let me just erase this. Probably. Okay. So now we have two types of indexes, index types. Clustered, non-clustered. Assume you declare this ID as a primary key. The moment you declare a column as a primary key, automatically a clustered index is created. Obviously, the index once again follow the same structure, the B tree format. Okay. There's no difference in that, and here you have these cutoff points from which where which data would go, and so forth, right? These are your nodes, internal nodes, and these are your final leaf nodes. Now, for a ID 5085, you are having a clustered index on this column. From the root node, you come and reach a point here. This ID 5085 is there. In a clustered index, not just the information that 5085 ID is here, but along with that 5085, all the column information for that record would all be available here. So let me have this pen color change. All the column information for that 5085 record is available along with that ID column, which means once you navigate using this clustered index and you reach the point, all the relevant columns are available then and there. Okay. As such, any specific columns now you want to select, you can select easily, very fast using a clustered index. Whereas if this is not a clustered index, for example, you have a column PAN number, and on PAN number you create a unique key. Whenever you create a unique key, automatically a non-clustered index would get created. So once again, for a PAN number, an index would get created, which would again follow the same approach of a B tree. And now you are searching for a specific PAN number, and that PAN number, based on the search, is present in this leaf node. But this time, it is a non-clustered index. When you create a non-clustered index and you have navigated from root node to this node to this node to this node, and here you have that specific record where PAN number A, B, C, whatever is there, that PAN number information. By the way, PAN number, those who don't know, it is a government issued number used for income tax in India. Okay. So now based on PAN number, you have reached here, but the difference is all the column information is not present here. Here what you will have, the memory address of where the specific PAN number record A, B, C, D, where the specific PAN number record is located in the actual table. which means when you are using a non-clustered index, you quickly find, using the B-tree way of storage, you quickly find out where the actual data is stored. However, the columns are not available here. The other columns are not available. As such, once you come here, you get the memory location, and then using the memory location, you have to come here and fetch the required column information. This becomes a two-step process. Again, non-clustered index also helps you faster retrieval of information because it helps you avoid full table scan. Only thing is, the retrieval in a non-clustered index is slightly slower compared to a clustered index. The benefit of non-clustered index as against a clustered index is you can have more than one non-clustered index. More than one non-clustered index on a table is possible. For example, you have customer ID, you have name, you have date of birth, and you have PAN number. Then you have Aadhaar number. Aadhaar number is like a social security number equivalent. Customer ID is a unique identifier which the organization gives to its customers. So that's why you will have a primary key here. The moment you create a primary key, automatically the data will be sorted by this ID. Now just think, PAN number, you declare unique key. Can you sort the same table by PAN number also? No. A given table can be sorted in only one way. If you are sorting the data by customer ID, then the same table cannot be sorted by PAN number also, because the moment you sort it by PAN number, the sorting of customer ID column will go for a toss. Then you have another column, Aadhaar number. Aadhaar number also you put a unique key constraint, assume. Again, will the data, this entire table, can you sort by Aadhaar number also? The moment you sort the data by Aadhaar number, the sorting by PAN number will go for a toss, or the sorting by the previous sorting by customer ID will go for a toss. As a result, we clearly understand that data can be sorted in only one way. As such, you can have only one clustered index. Whereas in a non-clustered index, what do you have? The data in a separate index table. There is a separate index table is created where the B-tree, in a B-tree format, the information is stored. And here this PAN number is there, and here the memory location. The data here is sorted by PAN number, and when you run a query to find a record with a specific PAN number, and it finds that okay, this is the record in the index B tree structure, it will give you the memory identifier, and based on memory identifier you can quickly come to the record and pull information. You avoid the full table scan. If you now create another index, clustered index on an Aadhaar number, there will be a separate index which would get created for Aadhaar number, where you will have Aadhaar and the memory location. The data is sorted here in this separate index table. The data is sorted by Aadhaar number, and when you search for a specific Aadhaar number, it will first come in the index table using the B tree structure. Quickly identify which record you have to pull, and based on that record, you will find the corresponding memory location, and then you can come to the main table and fetch the information. So the benefit of a non-clustered index is you can have more than one non-clustered index. The benefit of a clustered index is the data is sorted by the identifier on which you have created the clustered index. By default, automatically a clustered index gets created on a primary key, and because the data is sorted and all columns are available along with it, the query runs faster. Now the question is, can you have the indexes only on primary key and unique key? No, it is not necessary that you have indexes only on a primary key column or a unique key column. Any column based on which you frequently write select queries, you can create a index using create index, index name, on table, column name. This syntax, you can easily create the index. The point is, by default, for a primary key and a unique key, for a primary key, a clustered index gets created, and for a unique key, a non-clustered index gets created automatically. We will see one more table here. These tables we have created in our previous session. So here we have a trainer batch mapper and indexes, and the two columns together we created as a unique key. This is the syntax: alter table trainer batch mapper, add constraint unique. We created a key, automatically a index gets created, and if you see this, it will say trainer id batch id, a B tree is created, but it is not clustered. If I now see the primary key, it will say B tree clustered. If I see the second one, it says only B tree, it does not say clustered. This is the third one, batch id, it just says B tree, it does not say clustered, because you can have only one clustered index. You can have more than one non-clustered index. I want to probably create index on, say, name. Name need not be unique, and name cannot be primary key. Can I create a index on this? Yes, I can. I will write a syntax: alter table students, add index, give some name, idx to name, bracket, student name, semicolon. Let's run this. 0 rows affected, 0 duplicates, success, green tick. I come here, refresh it, refresh all, and indexes, I get here index idx to name. I'll say this create index is to inspect. I click here, it shows me that a B-tree index has got created. It does not say clustered. If you have the word clustered adjoining it, it means it is a clustered index. If the word clustered is not there, it automatically means it is a non-clustered index. So this is what we have on indexes. I hope you understood the concept of indexes. MySQL does not allow you to specifically write a syntax like this. Alter table, table name, add clustered index. In MySQL, by default, a clustered index would get created on primary key column. Assume you have a table where you don't have any primary key and you want to create one clustered index. Ideally, you should be allowed to, but in MySQL, we do not have this syntax. Okay, so in MySQL, on a primary key, you will have a clustered index. On any other column, you can create a non-clustered index. The benefit of indexes is it helps you retrieve data quickly from the database table. What is the downside of indexes? Assume you have a table and you have this customer ID, date of birth, name, PAN number, Aadhaar, and there are many other columns, gender, qualification, like this. Now you saw that, okay, hey, when I run a select query, my query will now run fast because of having index, as it helps me avoid full table scan. Then you would think, okay, why not create an index on this column? 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 So you may want to now start creating index on each and every column. The moment you start creating index on each and every column, for each and every column you will have a B tree. I hope you get the point. You will have a B tree structure getting created in the background. Okay. Now if you run a insert a syntax and you add a record, because of that insert, all the B tree structures, wherever you had the B tree, all of them has to be updated. As a result, insert will slow down. If you run an update, because of the update syntax, all the B tree will have to be updated. As a result, update syntax will become slow. If you run a delete, all the B tree has to be updated. As a result, delete will slow down. Only benefit that you are getting is in the select query. So we can say that indexes helps you run fast select queries. It helps you fast retrieve information from a table. The downside of having indexes is it reduces, it slows down your insert, update, and delete queries. Indexes benefits select query, whereas the downside is insert, update, and delete query becomes slow. as such, you need to have optimum number of indexes. You should not have many indexes. When you are designing your database for a transaction system, in that case, you should have indexes only on primary key and unique key. When you have the database being designed for warehouse is being created for MIS purpose, reporting purpose. In a reporting, you need to frequently run select query instead of insert update. Insert update happens once in a day or less frequently, but select queries are executed more frequently. You should have probably relatively more indexes, but not not have indexes on every column. You can relatively have more indexes on some of the columns on which you run the select query very frequently. Okay, so this is what we have on indexes. If we summarize, indexes are of two types: clustered, non-clustered. Indexes speeds up select queries, slows down insert, update, and delete query. With this, I conclude the topic of indexes. I hope you got the concept. Indexes is more about concept. Thank you. See you in the next session. In the next session, we will be discussing about generated columns and virtual columns. Thank you. Bye bye.